On the evening of July 17, 2007, TAM Flight 3054 was descending into a dark, rain-swept Sao Paulo. The aircraft's destination was Congonhas Airport. As you can see from this aerial view, its 6,300-foot runway is entirely boxed in by dense urban sprawl, leaving almost no physical buffer zone. Compounding the geographical squeeze, the tarmac itself was severely compromised. It had been recently repaved, but the airport administration opened it for operation before water channeling grooves could be cut. Under the heavy rain, the asphalt was a slick sheet of water. Bringing a heavy Airbus A320 to a halt under these specific weather and surface conditions requires absolute perfection from the aircraft's automated deceleration systems. On this runway, on this night, any loss of braking power guarantees a collision. The margin for error is effectively zero. Flight 3054 was operating with a known mechanical deferral. The thrust reverser on engine number 2 was deactivated, or pinned, a standard practice permitted by maintenance rules. To account for this, Airbus had established a specific computer procedure for landing. Crews must physically pull both thrust levers all the way back to the idle position upon touchdown. Pulling both levers back is the universal signal that tells the A320's central computers the aircraft has officially landed and is ready to stop. At 18:54 local time, Flight 3054 hit the wet asphalt at 142 knots. But in the cockpit, human muscle memory overwrote the new procedure. The pilot correctly pulled lever 1 back into the reverse zone, but accidentally left lever 2 pushed forward in the climb position. That single asymmetrical physical input sent a contradictory message straight into the flight computer, inadvertently springing a lethal software trap. The A320 operates on rigid logic gates. To trigger the ground spoilers, the panels that pop up on the wings to kill lift, the computer strictly requires that both thrust levers be set to idle or reverse. Because lever 2 was still registering climb thrust, the software assumed the plane was still flying. The logic gate rejected the landing sequence, and the ground spoilers remained flat against the wing. Without the spoilers deflecting, the aircraft's braking capability instantly degraded, immediately increasing the required stopping distance by 50%. Then came the second sequential logic failure. The automatic wheel brakes were armed, but their software code strictly requires spoiler deployment as a prerequisite to fire. Because the spoilers were locked out, the auto brakes were mathematically bypassed. The plane was rolling at highway speeds with zero automated braking. In less than 2 seconds, one misplaced hand blinded the aircraft's central computer to the physical reality that it was on the ground. 2.5 seconds after the main gear hit, the nose wheel slammed down hard onto the flooded asphalt. At this moment, the pilot pulled lever 1 completely into the maximum reverse thrust detent. This triggered a secondary computer protocol. Moving one lever to reverse officially disconnects the automatic thrust control. The computer executed its failsafe. Seeing the auto thrust disconnect while lever 2 was still physically pushed forward, the software activated a thrust lock to prevent uncontrolled acceleration. Engine 2 spooled up and froze at a high output value. The physical asymmetry was overwhelming. Engine 1 was roaring in reverse, trying to brake, while Engine 2 was frozen at climb power, actively pushing the fuselage forward and violently twisting it to the left. 6 seconds after touchdown, realizing they were not slowing down, the pilots crushed the manual brake pedals to maximum deflection. But the manual inputs were useless. The crew was now physically fighting an airplane that was flawlessly executing a fatal set of mathematical rules. The A320 finally lost the battle against the asymmetric thrust, veering off the left edge of the elevated Congonhas runway at 96 knots. It crossed completely over Washington Louise Avenue and collided directly into a fuel service station and a concrete TAM Express cargo building. All 187 people on board, along with 12 people on the ground inside the structure, suffered fatal injuries. This catastrophe resulted from a perfect alignment of an unforgiving environment and a catastrophic software misunderstanding. The tragedy of Flight 3054 lies in the disconnect in the cockpit. The crew lost situational awareness, fighting the physical symptoms of the crash without ever realizing the digital logic preventing them from stopping. It highlights a critical vulnerability in aviation training that relies heavily on muscle memory and rote memorization rather than deep systems comprehension. In a fly-by-wire aircraft, the pilot acts as an IT manager who must understand exactly how a computer interprets and executes their physical inputs. Strict adherence to procedure is not a matter of bureaucracy. It is the exact programming language required to survive. Fail to speak it, and the machine's safety logic becomes your executioner.